We have just taken an idea of what exactly we are doing in machine learning. So let's try to understand this in a bit more detail. Like, let's try to see with an example. Like, just assume that we are teaching a baby to recognize a dog or a cat. Okay. So what we do, we basically show a list of pictures of dogs and cats. During showing, we also say whether the image is of a cat or a dog, right? That we do. Like, this is dog, you see that is cat, or that is bird, or something like that. So I'm taking only example of cat and dog. If we want to teach a machine to recognize the same, we have to follow the same technique, right? Just like, instead of having the baby, we have the machine. That's all. That's the difference. So here a list of image are the inputs. I mean input data, right? And the name of the object, like dog or cat or some bird, whatever you say, is basically called label. Okay. In short, we teach with the help of a set of labeled example. Now, based on pattern of the image, something like this. We have a dog, we have a cat, something like that. Okay. So, based on the pattern of the images in the machine learns and can predict any image is of either dog or it's a cat. So, this is a very basic example of a machine learning. A very, you know, small example. Like, just like a baby, if I ask you that, tell me what is the name of that particular object, you can easily do that, say that. But remember, you cannot answer that particular object which you have not even seen. For example, dog or cat, in from any side. If I show you a picture from front, from back side, from side facing, from any side, if I take a picture and show it to you and ask you that, tell me exactly, is it a object of a dog or a cat, you can easily answer that. Why? Because actually your eye or your brain has been trained with different posture of dog image or cat images, and those different postures are the different variety of inputs data, right? I mean, you have not seen dog only from front, you have seen from back, from other sides as well. And that's actually the set of examples that we are talking about, which need to be pushed in machine learning also, I mean into a machine also. If I want, the machine will also learn in the same way. Okay. So let's take a short note what exactly we have learned. That firstly we have understood the limitation of traditional computer program, where we have no scope of adapting previous experience, right? Therefore, we have moved into teaching a black box that can learn from data, I mean a set of examples, without being programmed using preset rules. Preset rules means the instructions, the specific instructions that I'm saying. I mean, definitely there is some program we have to write, but that program does not make a specific rule. Rather, the program that we will write now will make we will for is for basically learning the machine. The instruction that we will write in the program will basically help the machine to learn. Anyway, so what exactly we are going to write in form of code, it's not clear right now to you. I know that, and you don't need to worry about that even. That what program you are going to write, how it will look like. So don't worry, you will understand it very easily. Just for now, you try to understand the the flavor of this machine learning and what's actually going to happen. Anyway, so now as a benefit, we no need to modify the program for the new data, rather in case of machine learning, right? So let's see, that mean we are talking about the machine learning black box for last few slides. We are saying, right, machine learning black box. Although we are not sure exactly what is present within the box, I hope one thing all of you can guess, at least, that that is the black box is some mathematical model. There must have some mathematics behind this model, right? The mathematical model accepts input in form a set of properties. Set of properties means, so for example, I want to say train a model which can predict the you know price of a house based on, say, its area, the carpet area, okay, the location of the house, and many more. Okay, so to do this, we have to train the machine first with some examples, previous examples, that for this type of carpet area, for this type of location, for this type of materials, this should be the price. In this way, we have a lot of examples definitely, and that example we will fit to the box, and from the bare box, what we will do, what the box will do, box will try to understand the hidden pattern between those between some, say for example, between carpet area and the location of the house and the materials used for designing the house with the price. So in one side we have the house price, in other side we have those three inputs. So those three inputs are called features. Technically, the inputs to the mathematical model or the machine that we are seeing is called features or properties. Like another example I can take, like if we want to design a black box, still I'm saying black box, which can predict the class of a student. Class means in which class, class 5, 6, 7, 8, or something like that, based on gender, height, and weight. Like obviously the weight of a student of class 5 is not same of, will never be same as weight of class 7, weight of a student of class 7 or class 10 or something like that, right? So there is variety of, if I assume that there is some pattern with respect to height and weight also, and the corresponding gender. Okay, so we can try to check that, whether there is any hidden pattern we can find between the gender, height and weight with class, right? And if I want to create a intelligent model that can predict the class of the student based on those three inputs, so what you have to do, you have to give these three inputs to the black box to train the model with some examples, as I just said. Here each and every example has three input features like gender, height and weight, and the outcome is the class. Now once the model is sufficiently trained with examples, we can use the model for predicting the class of an unknown student based on his or her gender, height and weight, right? But here a very vital question may come or should come in your mind, that is how we can assure that the model is sufficiently trained for predicting unseen data. Do I have any examination? For example, I'm teaching you, you are learning. How I will understand that you are sufficiently learned? I will say that okay, I'll take some exam, and in the exam I will definitely not put those examples that I have solved in front of you during teaching. What I will do, I will even not give you those examples or those problems which, I mean, whose type has not yet been solved in front of you. What I will do, I will give you some set of examples which I have not taught, which I have not solved in front of you, but those examples are to some extent similar to the examples that I have solved in front of you, right? That happens. So, and based on some, you know, based on the result that I am expecting from those examples and the result that you will produce or you will evaluate, and based on the difference between that I know that I know the answer of the problems, right? What I have given to you, for example. So for example, the answer is one. Answer should be one, and imagine you have got 1.5, so you have error zero point 0.5, but you will say, sir, it is examination. 1.5 is wrong. Means I should get 0. But no, it is not exactly the examination that we are going to conduct here. Remember, every time I am saying the black box is predicting something. If prediction come, then there must have some tolerance. Tolerance mean for example, for a particular, just I said, for a particular house, I mean for a particular carpet area or location or the materials used, the model is predicting, say, the price of the house should be 50 lakh. Now, is it really exact 50 lakh? Or maybe 52? Or maybe 43? Or 40, sorry, 48? Now, in case of machine learning, during prediction, you can never guarantee that whatever value that the model will give you will be 100% correct. There will be some tolerance that it's 90% correct, 95% correct, something like that. Anyway, so don't worry, how we will evaluate a model has sufficiently trained. We will come to this point definitely, and you will get the answer very soon. Okay, so let's do one thing. Let's see some practical examples of use of machine learning first. Okay, so let's start with this example just I shared with you. Like just assume that you want to buy a house, and before you decide a house, you may go through several houses and try to observe the features such as carpet area, local facility, number of bedroom, and many more. Right? Year of construction, maybe a very important parameter. Here, we can teach a machine learning model with lots of examples having all these features as input and the actual house prices. I'm saying it is an example. If it is an example, that means I have the full record of set of houses whose carpet area, local facility, number of bedroom, year of construction, and many other features is known, as well as their actual price is also known. And this is as a whole creates a data set. Okay. During learning, I mean, ultimately I want to teach a machine learning model, right? So during learning, the model can capture the correlation between the features and the prices, and this knowledge will be further utilized for predicting house of a unseen house based on those feature values. And what will be my benefit in this case if I do this? The benefit that I will get is like, if I give this set of features for some unknown house, like in my unknown house, I have this carpet area, this local facility, this number of bedroom, this year of construction, I will get a basic, you know, understanding that there is a probability of getting the price of the house in this particular range, something like that. Maybe 50, maybe, you know. Now, for example, you have must have some budget, right? Just take a practical situation. Like you will have a budget. Say, for example, 50 lakh. You cannot go beyond 50 lakh. I mean, a flat on of 50 lakh. Now, assume that there are 50 flats available, and each and every flat owner is actually giving some particular value. Now, what value it should be, you don't know, because the owners giving the house prices based on his choice. What you can do, you can, if you have an intelligent model where if you give these inputs, the model can say that based on this input, the price should not be more than 40 like 45. Then what benefit you will get as a consumer of the model, that you can at least start bargaining accordingly, right? But if you don't have this model, you don't have any way to get any relation, or if you don't, I mean, you don't have any way to understand what should be the price. Let's take one more example here. Like, we can try to predict the geographical region of a person based on several features like height, complexion, hair color, and many more. Like, for example, the people from hill area is a little bit shorter than people from some other region of the world, right? That we have seen. Maybe in case of cold places, very cold places, the people are generally very, their skin is very bright, right? So I'm just giving an example here. No, maybe with this example there is no such practical, relation, but you can have a model like this which will predict from where particular the person may belong. May, I'm saying may, again I'm saying it's not exactly belong, you cannot never guarantee. The person may belong from hill, or maybe from desert area or something like that, or maybe for some very cold place. Cold place does not mean hill is also cold, but cold place means, I'm saying, based on some, say, in very near to the some poles, south or north poles, or something like that. So this can be an example, and there are many more examples present, obviously. But just for understanding, I'm saying these examples, and in future we will go through not only example, but we will try to you know dive within the example and try to solve the problem in practical.